Hello grade 11s and welcome to the very last problem in the series of videos. This is the question on redox reaction, also known as reduction-oxidation reactions. Remember, acid-base reactions are proton transfer reactions, where those protons are actually hydrogen ions. But redox reactions are electron transfer reactions, so that's important to take note of. They say study the reaction below. Magnesium solid reacts with iodine to form magnesium ions and iodine ions. Look very carefully, you're going to notice very easily that this equation is not balanced, or this reaction equation is not balanced. Question 7.1 says, define the reducing agent in terms of oxidation numbers. Remember, the reducing agent is the substance which itself undergoes oxidation. Oxidation is the loss of electrons, and therefore when we define this in terms of oxidation number, we say it is a substance whose oxidation number increases. We leave out everything in between. If you include that, you're going to get 0. You just write down for 2 marks, it is a substance whose oxidation number increases. Question 7.2 says, identify the reducing agent in the above reaction. The reducing agent is the substance that is oxidized. And oxidation means to lose electrons and therefore to become more positive. We look at the magnesium and we see, since it is an element on the left, its oxidation number goes from 0 to positive 2. That already indicates a loss of electrons because magnesium is becoming more positive, and therefore the reducing agent is Mg. We can say it is Mg solid or just Mg. Iodine goes from having an oxidation number of 0 to getting an oxidation number equal to its charge, which is -1. It gains an electron and becomes more negative, and therefore it is reduced. Iodine is therefore the oxidizing agent. Magnesium leads to iodine being reduced. Iodine leads to magnesium being oxidized. That is the term agent. Question 7.3. Okay, so that is for 1 mark. Question 7.3 says, write down the formula of the substance that is reduced. So we have the reducing agent, it is magnesium, and we just identified that iodine, I2, is the substance that is being reduced because its oxidation number goes from 0 to something more negative. It gains electrons. 7.4 says, write down the balanced equation for 7.4.1, the oxidation half reaction. Which substance is being oxidized? The substance being oxidized is magnesium. So you can either think in your mind and write down these oxidation and reduction half reactions, or you can use your table of standard reduction potentials. I'm first going to write it out, and then I'm going to show you where you can find this on your table of standard reduction potentials. Magnesium is going to be oxidized, therefore it's going to lose electrons to form Mg2+. It loses 2 electrons. Every 1 magnesium atom loses 2 electrons to form the 1 magnesium ion. For writing this down, you're going to get 2 marks. But let's take a look at our table of standard reduction potentials. Here at the bottom, highlighted for you, is the reaction for magnesium. When taking a look at this table of standard reduction potentials, the reducing agents are written on the right-hand side, and the oxidizing agents are written on the left-hand side. So in this case, magnesium is the reducing agent. It undergoes oxidation, and therefore we write it out from right to left, just as I did at the top. Mg is going to form Mg2 plus 2 electrons. Question 7.4.2 says, write down the reduction half reaction. There we have iodine, I2. It is going to gain 2 electrons. The reason I say 2 electrons is because there are 2 iodine atoms and they are each going to form a charge of -1. One iodine molecule forms 2 iodine ions and it needs to gain 2 electrons. For writing this down, you're going to get 2 marks, but I'd just like to show you that you can also find this in your table of standard reduction potentials. By the way, over here I'm making use of table 4a. So over here we have our substance. Remember, your oxidizing agents are written on the left-hand side. So here is I2. It's going to gain electrons and undergo reduction to form 2 iodine ions. And that is exactly what we wrote out at question 7.4.2. The very last question says, write down the overall reaction. Step number 1, we check to see, are the electrons balanced? Are they equal in both reactions? Yes, they are. So we're going to leave out the electrons. We write out the arrow. What's on the left-hand side is magnesium plus I2. What's on the right-hand side is Mg2 plus the 2 iodine ions, and this is the overall reaction. We're going to give you 1 mark on the left and 1 mark on the right. What is incredibly important in this section is the charges. If you left out any of the charges, you do not get marks, okay? So make sure that you include the charges. Make sure that when they refer to the reducing and oxidizing agents, we go specifically to the reactants. On the right-hand side, we have the products and grade 11th. This brings us to the end of question number 7 and therefore the end of this series of videos. I'd like to thank you so much for dedicating your time to watching these videos. I hope that they helped you and I wish you all the best for your exams and for the rest of your future.